So good morning, good evening, good afternoon, wherever you are. My name is Vishnudat, and we are in class number two of AI for network engineers. Right? The agenda will be very simple. We will be talking about AI and LLMs. Are they same? We will be talking about maps, right, which we discussed in the last class, and how to correct this map, the model. If you are not getting what I'm saying, no problem. But the whole sole aim of this class is to getting you close to explain somebody what exactly LLM is or what exactly ChatGPT is, right? The other thing is today's class is going to take a little toll on your brain. It is means your brain will be doing some exercise today. So it is my recommendation after Hindi's class, please have a cup of coffee with you or maybe tea. I want your 50 to 60 minutes of complete attention, complete concentration, right? And I promise you, if you give that, some of the most interesting things are going to be with you. You will be learning the thing which people hardly try to understand. Almost 95 to 97% of the people do not know about. I'm not saying this, that I'm not saying this because I want you to be in that league, but I feel that you are curious enough because you are into this course. You have done the first class, and I believe you are curious enough to understand how LLMs work behind the scene. Without going into the mathematics, without going into the algorithms, we will try to simplify LLMs. I need your 50 to 60 minutes. Having said that, let's move to the new board. And this board are loving characters, right? Rahul and Anjali are talking with each other. Rahul is saying that yesterday's or the last class were phenomenal, but I have few questions on it, right? And Anjali is saying that you are most welcome. The first question from Rahul was, Ranjali, this course is for AI for network engineers. And now Vishnu is teaching all about LLMs, right? So it AI is equal to LLM. Means if I say LLM, is it AI? Or if I say AI, is it all about LLM? Interesting question, right? Believe me, Rahul is just a medium for me. But many of you asked after the first class that Vishnu, the course was AI for network engineer. What exactly means this LLM is? Is it AI? Right? And believe me, if you don't ask question here, please put your questions on WhatsApp and I will try to include them in my next session. The second question was even more interesting, right? Rahul is saying that I understood something with respect to creating the map of the word and giving the word's location. But my problem is at the end of the day, this machine is going to be the computer, right? And computer understand the numbers. If I give this computer a word, suppose I give this computer a word which is friend or friendship, how I'm going to explain this computer what is the meaning of friendship? How it is going to understand it? Because one thing we understand from the last lecture is it is all about language. And if something is there which is predicting the next word correct, it has some intelligence, it has some knowledge with it, some understanding with it, because prediction is not a cheap trick, and we have explained it in the last class, right? Prediction of the next word of language is very is a thing which requires lots and lots of understanding. Prediction comes with understanding. We have proven that. So these are the two questions, and Anjali said that yes, I do agree with you. We have to answer it. So let's talk about it. The first thing, whether AI and LLMs are same, right? Interesting pictures. I'll give you first an analogy. Suppose we have a vehicle. Vehicle is a container, right? For few things. We know under this category of vehicle, we have car, we have bus, we have bicycle, we have cycles, we have auto rickshaw, we have truck, and so many things, right? Can I say that car is a vehicle? Absolutely. Can I say bus is a vehicle? Absolutely. Can I say only car is a vehicle? No, absolutely not, right? If you understand this analogy, you understand the difference between AI and LLMs. If we talk about AI is a container for many things. If we talk about a face detection machine at the airport, this is nothing but an AI. If we talk about how YouTube, you are watching a video and when the video is finished, YouTube give you another video to watch because it doesn't want you to go out from the YouTube, right? How it is predicting the next video to you, that is again part of AI. If we talk about Google Maps, AI. If we talk about self-driving car, AI, right? But where exactly LLMs are? If we talk about ChatGPT, it is AI. If we talk about Claude, it is AI. The important piece here is if we talk about ChatGPT, the engine on which ChatGPT runs is your LLM. The engine at which your Claude work is your LLM, right? So I can say that LLM is AI, yes, but if I can't say that AI represent or AI is just only LLM, nope. So I think you understand the difference. But why LLM gets so popular, we understood in the first class, it is all about language. Wherever language is a raw material, in case of doctors, in case of lawyers, in case of software engineers, in case of network engineers like us, we all get money, we all get salary because we are very good with respect to language and we know we have experience in this field, right? Why LLM is so popular? Because a common man can interact with it. Common man can't interact with all the common men can't interact with the self-driving car. They can't interact with the face detection machine. No, right? Why LLM is so popular? Because it is talking to common man, and common man is getting the answers, right? That is why LLM are so widely spread. Everybody knows about it, and that is why we are learning them, right? So I think we all get the idea. AI and LLMs are the same. I can say LLM is AI, right? But AI is a bigger umbrella in which there are multiple things there. So if we are on the same page, let's dive, let's dive a little bit deeper into LLMs, right? So there are two ways to understand it. We are going a little bit deeper into LLMs, and two ways are I can explain you everything about LLMs by taking the example of English language, the full English language, which is having approximately 1 lakh words, but it is going to be overwhelming for everybody, right? So I decided to take an example, very short example. I have decided to take an example of a language which have only these 8 words. You must be laughing in your head. But to simplify things, and believe me, I am going to oversimplify all those concepts because we are not learning mathematics here. We are not going into the algorithm without mathematics and algorithm. We will try to understand what exactly LLMs are because we network engineers are always doing that. Try to understand. We know BGP path selection algorithm, right? We know if we have two prefixes, how to select a particular one, right? Because we know BGP path selection algorithm. But somebody come tomorrow and say, no, you do not know BGP path selection algorithm because you do not know how Cisco, how Juniper has implemented it. You do not know the real algorithm behind it. You do not know the linked list. You do not know the C++ language. And you will be saying that it is not the case. We understand the gist of BGP. We understand how it is going to select the route. Everything else is implementation. And that's why I wanted to tell you, we want to understand the gist of LLMs, how they are working without going into these mathematics and algorithm, right? So I'm taking an example of only 8 words language, very small language, which have only these 8 words. Why I've decided these 8 words, right? Because I can come up with 2 sentences from this word. One sentence is I love mangoes, right? And the sun rises in the east. You can all figure it out. And my goal here is the big goal here is I want to teach this machine something so that if I give this machine I love and predict the next word, it is going to say the next word is mangoes, right? I want to teach this machine such that if I write the sun rises in the, if I give this input, it is going to give me the output as east. You must be thinking, Mr. Vishnu, this is very, very simple. We can write a program for it. You can write a program for it, but you can't write a program when there are 1 lakh words and the combination and the sentence is huge. And this is what we have been doing from 1950s to 1980s. We were teaching machines or the computer the rules, and that was backfired. In 1980, somebody suggested, let's not write the rules, let's count the words. And eventually we come across something which is the word map. But here again, just have this picture to understand the bigger model, the large language models. To understand that we are taking just one simple language which is having 8 words. These are the 2 sentences, and the goal is if I give these 2 sentences, the machine will be predicting the next word very well, right? So how I am going to teach this machine? And by the way, teaching means training. I want to train this machine so that it can predict the next word. To do this, some intelligent guy came and he said, and we have discussed in the last class also this, that we will be giving these words a particular location. Because machine can't understand this word, we will be giving these machine numbers instead of words. And these numbers are going to be the location of these words. What is the meaning of location? So what this guy did, he took all these 8 words and just throw them on a piece of paper where we have the map, right? And that is the next board. What this guy did, he took all the words and put them on this map. And of course, any word can take any position, right? But the whole sole aim of this guy was that the words which are aligned with each other, which mostly comes in a sentence, should come closer, right? I would like to give an example of the particular aim of this guy is, suppose we have a wedding ceremony and there are maybe 1000 people in this and all came at once. After some time, what you are going to see that there are going to be groups of people, 20 people, 15 people, 12 people, like this, right? What is this group? This is a group of people which align themselves, which have the common interest. I'm not saying that we need to combine or make those words closer, which are synonyms. No, I'm talking about the work which align themselves. For example, cat and dog. For example, water, milk, juice, alcohol also, right? This is going to be aligned. But to begin with, I just took all the words, I just throw them on this map, and believe me, these words will be getting a number. For example, this is just nothing, but I can say this is my x-axis, this is my y-axis, and if a word rises is here, I can define the position by taking the x-axis and y-axis. If you don't comfortable with it, that is perfectly fine. I just want to tell you that instead of love, I will be knowing love with these 2 numbers which represent the location of the word love. Right now, I is quite far away with it, but if you see a lot of data, I and love are together, right? They align with each other. So eventually what I want this I to be closer to love. So that if I want to write a sentence after I can say what would come after I will be predicting love because love is nearer to I. I will not predict mangoes. Maybe mangoes is far away. But to begin with, this is my problem. To begin with, the problem is I do not have the location. I am giving them any random location. I am just throwing them on this piece of paper where we have map. And in this map, every word is going to have a location. For example, if we talk about India here, where this in is, India will be having a location. We were discussing about it, longitude, latitude, right? But now the question arises that why are we throwing it on a piece of paper? We can also throw it in a space in this room, right? And that exactly I did in the next board. If that is the case, again, these word will be somewhere in the room. And now I have increased one more number. Why? Because now I have another dimension, X, Y, and Z. And I can define this number with the 3 numbers, right? Again, if you are not comfortable, that is perfectly fine. No worries. I am just saying that these words can be defined with the location, and this location is just nothing but the numbers. And to begin with, these numbers can be anywhere. Now the problem arises. The problem is human brain can think in 2 dimension as well as in 3 dimension. But if I add one more dimension, human brain can't think. I can easily calculate the distance between the and rises very easily by if I have the location between them. It is just like calculating the distance between India and USA, which are on this map. And if I have two coordinates with them, latitude and longitude, and then we can calculate the exact distance between them. Who is closer to what? Very, very easy. But believe me, there are many more dimensions. And if you try to think about it, you will not be able to think about it. The reason is the human brain can't think in more than three dimensions. But the mathematics which I'm talking about, it can work in any dimension. For example, if I want to define this mangoes by 50 words, by 50 different numbers, the mathematics will be working with these 50 dimensions or 50 different numbers. Don't worry about it. Mathematics do its job. So overall point till now is, right, we will not go into mathematics again. I'm saying I have only 8 words. The goal is to align these 8 words such that I can predict the next word if I have two starting words, right? For example, if I have I love, then the mango should be close to it, right? If the mangoes is close, I can figure it out. Devi I'll take your question, right? But if you are again trying to think in more than 3 dimensions, believe me, you would not be able to. But why do we need more than 3 dimensions? The reason is simple. Suppose I have this word I will be would like to want to be close with many other numbers, love, and so many, the, right? Not the, by the way. I can't have I placed to all the words which might be near to another words and so many, right? In just 2 dimensions. If you are not visualizing it, that is okay, but consider these 8 words only. If you consider these 8 words, the whole soul game is that we would like to make sure the words which aligns together are nearby, are near to each other. Having said that, let's move to the next board and you will be amazed to see what is happening. And if you understand this board, you will be getting almost 50% of the understanding of LLMs. Believe me. Just 10 minutes of full concentration. So I think we are good with respect to here. I am having these 8 words, no doubt about it. And these 8 words are going to have some location. The interesting thing is now I do not need to give machines the words. I can give machines the numbers instead of this, right? So it all begins. That means that these numbers, whatever I have, 270.5, these are any garbage number. In fact, you can say all are 000. Because to begin with, I do not know. My whole soul game is to arrange these words, the align word close to each other. This is the whole soul game of this activity which I want to do. Because if I can do that, I can predict the next word, right? But how I'm going to do this? Suppose I have taken a machine powerful enough and I have given this machine 2 words, the and sun. You all are very intelligent. You know the next word is going to be rises, but machine doesn't know about it. And I ask machine, right? And by the way, right now, I haven't given this machine to you so that you can write your queries, you can write your prompt. I am still teaching this machine to predict the next word. So I am just saying that we have 8 words in the language. I am giving you 2 words, predict the next word. And this poor machine doesn't know anything, right? Machine is saying, okay, just give me the location of the word the location of the word sun. Although this location is also garbage to begin with, because anybody just took these numbers, just took this word and threw them in 3 dimensional space or any space, right? Or maybe on the piece of a paper. So they have taken any position, no logic. But machine is saying that to predict, I need the current coordinates. So what I'm going to give the coordinate, which is going to be 2, 1, and 9. And I'm going to give the sun coordinate, which is 7, 7, 9, right? Then the machine says that I have number on my own also. What I'm going to do, I will be taking these 2 numbers, means these 6 numbers, and I will do some mathematics with my numbers, and then I will come up with a new location. A, B, C. Very, very interesting. Everything is going just like that. Guys, these are the numbers which any arbitrary garbage numbers, everything, right? Even the machine number, machine has taken any number. What is the meaning? You remember the last board? In the last board, I have put all these 8 words, right, in space. And now the machine has produced a location, which is this one, right? What is the whole sole job of the machine? The machine job was to predict the next word. What is going to be the next word? The sun, after the sun. And machine is saying, calculate the distance. Whoever is closest to me, it is going to be the next word. This closeness definition is different, by the way, right? Maybe it is in the same direction. Let's leave about it, but we will try to talk. The words which are more aligned to me are actually closest to me. And as mathematics word, we can calculate this distance between this new point, which is given by the machine, right? And on the basis of what number is very close, I am giving it high probability, high percentage. For example, I am giving mangoes 80% because this is what I calculated, right? Machine said. The 4%, 1%, sun 0.5, rise is only 5%, love 1%. How I am calculating this number? I am calculating these numbers, these percentage on the basis of machine predicted value, and we call this value as a ghost value because this is the value, this is the location where no number was there, but yes, number were there which are closer to this, right? And on the basis of this closeness, the more the number, the more the word close to me, I am giving it a high probability, high percentage, right? So in this case, very near to this location given by the machine, ABC location, we have a word which is mango, and that is why we are giving 80%, right? And that machine is going to do that on the basis of whatever you have given me, the sun. The next prediction is mangoes. Very, very absurd prediction. Wrong prediction, right? This is what we want actually. And you must be thinking, why we want the wrong prediction by the machine? Because if machine is predicting wrong, there is a chance to correct it. And this is the whole soul game of the training. To begin with, all these numbers are garbage, guys. Nothing, right? We can start with a zero, any arbitrary value we can start. These numbers are garbage, and that is why the number which is produced is also garbage, and that is why this result produced is also garbage. Mangoes is 80%, but now I can say, because this is the training phase of the machine, right? I give input the sun, and then I tell the real sentence was after the sun rises should come, and machine do this calculation that I predicted mangoes. The real thing is risen. I need to calculate the difference. This is my error. This is the error which I have done. I have to correct it. See, in the forward direction, machine has predicted mangoes, which is wrong. Then it is fed by the right value, which is rises. There is a difference between these two. Machine did the error. And now, when machine did this error, machine understood that I made an error. I need to adjust. What exactly it need to adjust? See, what has produced these values ABC? ABC was produced by these two location and the machine numbers. What machine is going to do? Machine will change these numbers X, Y, Z a little bit so that it can give maybe the closer answer or the correct answer in the next run. Similarly, machine is going to say that, see, I have changed my number, you also change the location accordingly, so that next time maybe we will be talking about rises. Maybe next time, instead of giving mangoes 80%, this number should be 80% or the 90%, right? The machine is going to change this number in the backward direction. Actually, we are going back to fix these numbers. Machine will be fixing its number, and it is nudging, it is saying that you change the location also of the and sun so that maybe they can be more closer to the word rises. As simple as that. This is exactly what is happening, guys. And believe me, these numbers can be calculated using an algorithm known as gradient descent. If you were in my machine learning course, I have explained the mathematics behind it. I do not want to do it here. But try to understand what we are doing. We are guessing the next, we are guessing or predicting the next word. It is coming wrong. We know the right word should be rises. Machine has predicted mangoes. There is an error. So I can fix this number accordingly, right? Very, very interesting. And I can fix this. And by the way, with only one sentence, I cannot change these numbers drastically. I change these numbers a bit. And I will be feeding this machine enormous amount of data, which can be formed. Maybe right now we have only 8 words, but with 1 lakh words of the real English, we can have almost whatever is present on internet, Wikipedia, anything, right? Anything ever written. If I feed this machine, slowly, slowly, by making mistake and by correcting it, it is going to change its numbers as well as the location of these words. Eventually, just like the marriage example, the words which are aligned together will feed together, will be really closer with each other. This is what exactly happening behind the scene. This is how this machine is learning. This machine is changing actually. This machine is actually changing these weights. But now the question is that who has this capacity to change or do this machine again and again, or say this machine again and again that you are right, you are wrong, you are right, you are wrong, right? Is it a human is needed? Try to understand, human is not needed here. We have so much of written content already available. The sun rises in the east is written so many times in so many words, right? So what we are going to give, we will be giving this machine input whatever we have written form already, but we are not going to show this machine the entire input. We will be showing this machine one word at a time. We will be saying machine the predict the next word. Machine will be predicting any garbage, maybe mangoes, right? After that there is going to be mangoes. It is wrong. Then somebody will suggest in your vocabulary it should be like the sun, right? If that is the case, then it will take the input the sun and predict the next word. Instead of predicting rises, if it predict maybe east, then it is wrong, right? It will change all these numbers accordingly, and then it will be having the right answer, right? We will be then these three. So basically, you can consider if we want to give this machine this input, the sun rises in the east. What we are going to do, whatever is there, we will put behind the curtain, we will give machine this answer. Machine has to predict, it will be predicting, and then we will show the correct one is sun. Then it is going to rearrange these numbers. Then we will be giving the input as the sun. We do not need a human in this, right? We just need to tell machine one word at a time. Although with the recent advancements, and that is why we are capable of doing building so large LLMs that these machine can read these words in parallel, right? So it is fast. But overall, let's not go into all those things. I just want to tell you only one thing. We give machine the sentence and ask it to guess the next word. If the next word is wrong, right, then machine has to adjust these numbers. And we will be feeding the enormous amount of data to this machine so that on every turn, machine is going to change these numbers. And how it is changing, it is making them correct at each pass. For example, it knows the correct answer is going to be rises, but it has predicted mangoes. It means that it knows which numbers to change so that the next answer in the next pass, whenever it goes, basically the percentage of rises should be more. It needs to change this number. It needs to change the number of this map also. As simple as that. Guys, 33 minutes have gone. After this, I asked in Hindi class, and there were so many questions. So guys, if you guys have any doubt, any question, please do ask me. Anything which is coming to your mind. Devi has hand raised. Mr. Devi, please ask a question. Please go ahead.
Hello, sir. Am I audible?
Yes, you are.
Sir, the first question is like, what is the significance of giving multiple uh, dimensions to these words? Like, you say we can give n number of dimensions. Is those dimensions are being considered to align the words? Like, let's say if we have more the dimensions, more the chances are that this will come together. Words.
Yes, this is the whole soul point. For example, means I can explain you with 2 dimensions example, right? Suppose we have only 2 dimension, Devi, right? I have this word I, which needs to be closer to love, which needs to be closer to M, right? Which needs to be maybe closer to eat, right? But the problem is this eat needs to be closer to something else, which is right here, right? Then how you are going to align this and this? In 2 dimension, is it
Right.
is not possible. We need to
No,
increase
no,
one more
yes.
dimension. Now consider 1 lakh words are here, right? How are you going to basically meet this eat everywhere? Here also, here also, here also, here also. That is where we need more dimension. And do not worry, if you visualize it, you will never ever understand. So the engineers of machine learning and AI, right? They say that mathematics is going to work in any dimension. We have to find the closest, we have to find the most aligned number with a point, and we can do that in any dimension. Okay?
Answer one more. Yeah, one more thing is that can you go back to our previous slide?
Yes. This one?
Right. Uh, the X, Y, Z are the, like, let's say it's a equations on which we'll put these numbers and then find out the machine number, which will again then compare, like, let's say I have rice which has 3 coordinates, love which has 3 coordinates. Uh, this X, Y, Z will be like, will turn into an equation, and then we'll feed this coordinate and we'll then find out another word,
Yes.
Z,
So
from
basically,
there.
this yeah, your intuition is absolutely correct, but I do not want to go into that mathematical function because it will take some maybe 2 or 3 classes, and it is not going to give you anything, right? We do not want to understand how BGP is implemented in the code. We just want to understand that what exactly is happening behind the scene, right? Leave the equation, just try to understand that machine is putting some of its numbers so that it can combine the and sun with its own number and generate this ABC, so that if this number is not correct, that it can change its number as well as the and sun, so that it can give you something which is more closer to rice. Babyji, am I making
Yes,
any
sir.
sense?
Yes.
Yeah,
Right, sir. Right.
perfect. And this is the whole soul game. And by the way, this back arrow is known as back propagation algorithm, right? Which you have seen. And basically, you will see this machine is going to have many layers, and this is known as the neural network. This, whatever we have written here, is the input layer of the neural network, and this is basically the output layer of the neural network. Whatever is happening inside, and without explaining neural network, I have explained what exactly is happening inside the neural network. Okay, back propagation means I am giving some terms so that you can talk in terms also. If I have predicted a wrong value, if I have predicted a wrong word, I have to correct in the machine the numbers. Whoever is responsible for this wrong word, I have to correct those numbers. Machine is going to nudge these numbers in these word map also, that dude, your position is not correct. If it was correct position, I would have guessed rices, not mangoes. So you change, I also change, and maybe next time, and you change a bit, I change a bit, so that next time we will be predicting the rises. But in the real world, on the basis of one turn sentence, we can't change the probability drastically because there is a huge data. Every time we are getting the sun, every time we are deviating, we are telling the machine to adjust and try to understand. In billions times when we give this data, machine is going to adjust every time, and eventually all these numbers are aligned somewhere in the multidimensional space which we can't imagine. But eventually
Uh,
they will be, right?
so just a last thing. So in the backward direction, we will also change our coordinates, and the machine will also change its coordinate. Then they will
Yes,
again realign.
yes, you are right. And you will be amazed to see, I will tell you, these the coordinates or the positions or the numbers in the machines are way more than the numbers which we have written with the words. I will tell you. But thank you so much. Gaurav M, please do ask your question. Gaurav?
Yeah, I hope you can hear me.
Yes.
So,
Yes.
okay, I understand that dimension may be a little more mathematical to discuss here, but do we have any idea of how many dimensions are there involved in this whole scenario, or how many can be there?
Yeah, so basically, if I talk about ChatGPT or these, whatever the open model we have, they have around 1000 dimension for a particular word. So to align these words in the multidimensional space, we need that many dimensions. The more the dimensions, they say, the better is the output. Gaurav?
Okay. And I mean, I'm assuming that these are algorithms that each of the proprietary AI companies own, right? Of number of
No, this is
dimensions
pure.
and things like that.
Believe me, it is open. It is open. It is. The number of dimensions they are choosing, the number of hidden layer they are choosing, it is proprietary for the every company. But the mathematics is quite open. It is just the 10th or 12th grade mathematics means linear algebra, which introduced having vectors and probability. Believe me, there is more than enough to understand this. And you will be amazed to see the matrix multiplications, the addition which we do in 11, 12 standard has a huge importance here. So
Mhm.
overall, the things such as the hidden layers, such as the number of dimensions, it is proprietary to the company. They do not release it, but sometimes means when I get a number from the open model, it was around 1000, and the layers which these means I am showing only one layer of the machine, but almost hundred of layers, such layers were there. But why those were there, we will be coming on to that. Gaurav.
Okay. Okay. One of the questions that I have is, I mean, maybe a small question. So this ghost value that you told about, right?
Right.
This is just a random value to start with, right?
To begin with, everything is random. All the numbers are random.
Okay.
The whole soul game is to come up with a number which have something so that these words are aligned eventually.
Okay. Okay.
Right?
And my last question would be, when you talk about back propagation,
Mhm.
right? You said that a change has to be made on both the sides, right? The machine would
Yes.
change, and
Yes.
then it will. So who would be changing the other side? Uh,
Machine is going to nudge it that these are whatever the number you are giving. If you change, if these numbers are this, then the result would be little bit closer to rises.
okay, and this data is processed word by word, not like in bulk. Right?
Nowadays it is see it is happening word by word. The curtain example which I'm giving, it is exactly like that, but now it can happen in parallel. For example, one machine I
Okay.
will be
Yeah.
showing the, and then it has to do the it has to predict the sun. On the other machine I have given the sun and it has to predict the next word. The logic is going to be same, but these things can happen in the parallel now.
Yeah. I mean, I guess that is what GPUs are for, right? I mean.
Yes.
Okay.
Perfect.
Okay. Understood. That is it. Thank you.
Great. Shreya, I think you had a question, but you lower your hand. Means if you had question, please speak up. That's fine. Shreya Gupta, or maybe you got your answer. Abhishek Di, please ask your question. Abhishek Dimri.
Good evening, sir. How are you?
Good
Uh,
evening, ji. Good
I
evening.
have I am having one question. Miss these value, if you are saying miss these are random or
Mhm,
these are fixed, because if the one person is writing the sun rises, right, as
mhm.
you said, so some values are coming 111 and another person is right the sunrise same time, and it may get changed or it will be remain same as 111, or it
Means
can be 123
see.
also.
Right now we are just teaching this machine. I haven't given you. I haven't given
Okay.
you this machine to play with. Believe me. Let me do the training, right? And then we will give you this machine also to play with in today's class only. Okay. So right now what I'm doing, I am just feeding it enormous amount of data. Although I have 8 words, but if you consider 1 lakh word of the English, then I am giving entire internet data. And every time it is reading, it is just changing this number in the backward direction, right? Finally, suppose I have fed it almost 90%, 95% of the internet data. The remaining 5%, whatever I am giving it, it is not changing anything. It means that it has changed enough. The numbers have already aligned, right? And my training is complete. This is where I will stop. Okay, Abhishek? But I will come to your point also. Don't worry.
Yeah, thank you, sir.
Perfect. Shreya ji, please ask your question. Shreya Gupta.
Hi. I just have a little doubt. So when you say
Mhm.
we we feed the machine, right? So you're saying that on we enter like sunrise and east, so it's going to keep it in its memory, and like there'll be multiple people feeding the same thing. So is it going to fetch from there, or it's going to do its calculation?
No, people will come at later stage. See, right now we are in the process of training this machine, right? We haven't given it to people to work on. What right now I'm doing is I have a computer and I have one article. Suppose I am
Mm-hmm.
this machine and article. In that article, only one line is written: the sun rises in the east, right? And it is
Mm-hmm.
learning from that. How it is learning? I am just giving it the, and I am asking it to predict the next word. Of course, because we have just started, it doesn't know anything. It is going to predict very wrong word, right? Maybe the mangoes. And I'm going to tell the machine that the next word is not mangoes, the next word is the sun, right? It predicted
Yeah.
mangoes, the next word was the rice. It is going to change the numbers accordingly, right? And then basically after the sun, I'm going to give it the third. I'm giving it the sun and I'll ask to predict the number, right? And it is going to do that. This process will go and go on until and unless we do not have any change in numbers. And if these numbers are not changing, it means that the machine has learned. Then we can talk about what we can do with the machine. Okay, Shreya?
Okay. So, like, how will you do that? So you're going to tell the machine, right? This is not correct, right?
Yes. So that is what basically we can
Yeah.
write a simple program for this. For example, as I said that the sun rises in the east. I'm not going to give the complete sentence. I will be giving
Mm-hmm.
maybe suppose the starting two words and put a curtain over
Okay.
it, right? And then when it guess the next word, predict the next word. If it is wrong, I will be saying you are wrong. Not I. The program will be saying the next word is rises, but you have predicted mangoes. Correct the numbers. See, the whole sole goal of this
Okay.
activity is to adjust the numbers, not not
Mm-hmm.
to predict the right word. We will be predicting once these numbers are adjusted, once these words are aligned themselves. Okay.
Yeah, I got it. Yeah.
Yeah, perfect.
Thank you.
So whoever has asked the question, please lower your hand. I could see a lot of question. Then I can go to Mr. Mandar Tambe. Please, Mandarji, ask your question. Mr. Mandar.
Yeah, hi Vishnu.
Hi.
So basically, these numbers, is it like I'm a little bit confused with
Mhm.
neural networks are having a lot of neural systems. Like for example, 1,000 layers are there. Like it's like trying to understand in 1,000 different approaches. Like what I want to say, if human is actually learning something, we see in a multiple dimension, right? So same way, this number is like different ways to analyze the data. Is there any analogy to
Yeah. So
human thought
so right
process?
now, see right now you just think this means I am saying it's a neural network in the middle, but you leave the neural network concept. Just let it
Okay, okay,
go out from your mind,
sure.
right? Just try to understand. I am giving this machine two locations. That's it, right? And
Okay,
machine using its number is creating one another location. Okay. If this location is predicting the right answer, it is good. If it is this location is not predicting the right answer, if it is predicting mangoes, then basically we can do the simple thing of changing these numbers, right? Whether it is happening through neural network or maybe any other network, it is the behind the scene. It is the mathematics. Neural network is just nothing but the mathematical function. That's it, right? So overall, try to understand the gist. On the basis of two inputs, the and sun, machine has predicted one thing, ABC. Closer to ABC, mangoes is there, which is a wrong answer. And I said, mangoes is wrong, rices are correct. Adjust yourself. Mandarji, making sense?
got it, got it. Yes, yes.
Perfect. And this can be done easily, believe me. Means if you really want to go and understand the mathematics also, Mandar, it's very simple. In my machine learning course, I have exactly taught this. One algorithm is there,
Okay,
gradient descent, and gradient descent on the basis of that, we tweak these numbers, right? As I said
okay,
again, it is not a rocket science. It is just the 10th and 12th mathematics. And the most simple piece is that in 12th we used to love matrices a lot. It is there, vectors a lot. So basically, if you have that kind of passion with mathematics, it is very easy. Again, I'm saying, but here, as most of the people really do not want to go into the mathematics, and we do not have enough bandwidth for that also, and it is not going to give us any result also. That is why I just still am saying we are just tweaking the numbers on the basis of input and output. That is it.
got
Okay,
it.
perfect. Mr. Burak, please ask your question. Please go ahead.
Okay, thank you, Vishnu. In this scenario, how the machine gets the benefits of the GPUs?
Okay, so right now, as somebody asked that, are you giving this input one by one or are you giving this input in parallel? Right? So GPUs has one specific property. They are very good in repeating the same task again and again, again and again, right? And try to understand. Means if we have parallel GPUs, right? And if I want to train enormous amount of data, extraordinary amount of data from the internet, right? In terabytes. If I give it to only one machine, one GPU, it will cry, right? But if I give it to 10 different GPUs in parallel, then basically it is going to be faster. And this is how we trained the LLMs. We are just training only LLM on a 8-word machine. But if it is going to be 1 lakh word, we need GPUs, which are very good in processing one single type of a job. Am I making any sense, Burak?
Okay, Vishnu.
Perfect. I think Abhishek and Devi has asked the question, and I will, if not, if you have another question, I will take the question at the end of the class. But this is what the entire gist of today's class. And Lalanji said, just like the Palo Alto processing, right? Parallel processing. Okay. Then the next thing, I think I have taken this example again and again, the same thing. Now I have included rises also, right? So what machines inputs are going to be 270.5 from rises. From the it is going to be 668, and from the sun it is going to be 779. It is going to have its own inputs. It will create another value ABC, which is again a ghost location. We will be reaching to this ghost location and finding what are the words closer. We found 60% match for love. It means that the machine is predicting after the sun rises, the next word is going to be love, which is absolutely wrong. We are going to remove the curtain, and the curtain will say the next word is going to be the sun rises in, right? And then machine is going to calculate this error between love and in. It is going to adjust XYZ. It is going to adjust these coordinates also, the dimensions also, and again this process happen, right? Sometime the next value is going to be correct also. For example, we have I love as an input. We ask machine to predict. Again, the value which will be going inside the machine is going to be 110.5, which is from love. I is 380.5, right? It will mix, produce ABC. Again, the ghost value, we will find the numbers, and the next number is going to be mangoes because it is 80%. And I love mangoes is the next word. It means that mangoes is predicted by the machine. Mangoes is what was the next word. There is no error. It means that nothing needed change in XYZ, the machine numbers, as well as these numbers. These are good. But believe me, machine gets very smart when we get an enormous amount of data. It is just tweaking these values. It is tweaking its own values through which it is coming onto this ABC, right? If we teach this machine, if we give this machine enormous amount of data from internet, it will produce the numbers which are going to be so accurate that every time it will give you the next number or the next word which is always correct. In today's world, these machines are predicting the next word, right? And that is why it is able to write the sentence. With the next word, it is able to write the paragraph, essays, articles, doing research, right? It is getting even better than humans because almost every human is using these LLMs to write their emails, to write the configuration, to write the articles, and so many other things, right? The whole sole point is when we give this machine data of enormous scale at every pass, because passing this word, this sentence is one pass, and if we are doing it the billions of time, it is nudging these numbers very little every time. And believe me, at last, means we have fed means almost 40 terabyte of data from internet, and the last 5 byte we are giving it, there are no change in numbers because there is no scope left to change these numbers. These are already aligned. If that is the case, this machine and these numbers are forming one thing which we know as model. So model is what? Where after the training, once these numbers are freeze. Why these numbers are freeze? Because whenever you give any input in this training, these numbers are not changing. They are already aligned. And if they're already aligned, they are forming something you can say extraordinary, and that something is your model. So model is just nothing. Model is your numbers, machine numbers, as well as the location numbers, right? If that is the case, we remains with a model. Now all these values, I love mangoes, these are going to be aligned along with these value of this machine which are inside this, right? So if I say I am downloading Olama, which is an open source model, what actually I am downloading? I am downloading these numbers. You know why? Because now these numbers has understanding. These numbers has intelligence. This number has knowledge. And as I specified in my last session, last class, predicting the next word is not a cheap trick. Predicting the next word comes with understanding. You cannot do this in language by using any trick. So basically these numbers which are frozen after enormous amount of data or after enormous amount of training. These numbers are the intelligence with which model come. And now I'll tell you one thing. When we download Ulama, it is going to be maybe 16 GB file. That is it. And try to understand, we have trained this on 45 terabyte of internet data, 45 terabyte. So if it's still this is in your image that the whatever the model we use, large language model, it has all the information from the internet. It has this 45 terabyte. Nope, it doesn't have. It just have these numbers. And if you ask me what is the meaning of this number, no one on earth can tell what is every row means because we can't visualize it, right? But we can tell them after feeding machine this data, these numbers are fixed. And if these numbers are fixed, if we give it the input, it is going to predict the right value. Why? Because it has those numbers, it has come on these numbers after lots and lots of training. I could see a lot of hand raised, but let me finish this. Now, when you download the model, it comes with these numbers. It comes with these numbers of the dictionary. It comes with this number of this machine predicted value. These got freezed. We were talking about XYZ, right? And now if I give this machine the sun rises in the, it will get the coordinates, whatever we have, it will mix them with this number. It is going to produce this value ABC. And believe me, because it is trained, these numbers had some value, meaning now, right? It is going to produce East, which is 92%, and it is going to write it here. Every word we will be calculating from this ghost location, right? Whoever is closer or closest will get the highest probability or the highest number, otherwise the lowest number. And who will be getting the highest probability will be here, right? Sometimes after this number, maybe even after the training, right? We give some input in a way that machine predicts something wrong after that. And that is why we are saying that machine are hallucinating. It is not right there. How come this model, which is fixed now with these weights, are producing the new things which are not there on internet? See, it can do that now, right? Why? Suppose I give it something. Can you write Newton's laws of motion in Bollywood style? Right? It has that Bollywood. It has that Bollywood aligned words. It has that Newton laws of motion. It can figure out the next sentence or the next word which is closer to this, and it will write the Newton laws of motion in the Bollywood, which has never ever written, on the basis of this closeness only. Try to imagine this machine is now generating on the basis of these numbers, on the basis of this intelligence. And this is what we do. As a human being, we have all the words in our memory, right? And we think what number, what word should come next, right? If you ask me to write Newton's laws of motion in Bollywood style, I can say something because I know the Bollywood context. I know the context of Newton laws. But if you give somebody who doesn't know the Newton laws, he cannot write in a Bollywood style. Overall, the point here is once the training is done, these numbers are freezed. And if these numbers are freezed, right, whatever we are giving as input, it is going to generate, it is going to calculate the cost. and it is going to calculate the value of everything, every word which is closer to it, and it is going to predict the one which is having the highest probability. This is my model. Having said that, we have lots and lots of questions, but before that, just let me complete only two things. Okay, we can see we have shown everything till now on 8 words, but we can extend this. We can have the bigger machine here, we can have numbers here, and right now we have only 6 words, but in human or in English, suppose we have 1 lakh word, we will be having 1 lakh rows here, and maybe we will be having, say, 1000 dimension. What we are going to do, we will be feeding internet data one word by one word, right? But on several machines, on several GPUs in parallel. If that is the case, machine will be predicting the next value on the basis of whatever we are giving, right? If it is wrong, it is going to adjust these numbers. It is going to adjust these numbers. Finally, we will be having something like this and something in the machine itself, right? Combining them is going to give you the real model, right? But in the real world training, basically more than one layers exist. The output of one layer is going to be the input of the next layer, and eventually we will be coming across a ghost value, and the nearest value will be that all the things are going to be absolutely same. But why we are introducing 2 layers here, not one layer, is why not one layer is enough? And the reason I am going to give you in the next class, when we will bring attention into the context. What is the meaning of attention? For example, right now, if I say word bank, its location is fixed, but this word bank can have multiple meanings. If I say I want to take money out from, then it is going to be this bank. But if I say I want to have a fresh air near the river, I am talking about again bank. But how come different word will result into this bank itself? And that is where we need to understand the complete sentence to know the meaning of the next word, whatever we are predicting, right? We will be talking about the multiple layers in the next class, right? And then we will try to download a model from internet and try to run it. But now your perspective towards a particular model should change. What is the meaning of a large language model now to you? This box is filled up with the numbers which are freezed now. We are going to give this as a query or maybe a prompt. It is going to generate the output. On what basis? On the basis of this number. These numbers are its intelligence, which is formed by training of this data. This training required a lot of efforts, a lot of CPU, a lot of money. And I think somebody was saying that to train the latest model of ChatGPT, I think it took around 100 millions. But I think DeepSeek did it in way less price. But what is the meaning? I think you understood. Whatever these numbers are, these are known as parameters of a model, or these numbers are known as weights. These things are same. So sometimes they say the parameters are billions of parameters are there. But if you calculate in my starting stage, how many parameters were there? If I say for one word, we will be having 1000 dimension, and then we have 1 lakh word, right? Still, we will be having only, I think, 100 millions parameters, and we are talking about billions. So from where other parameters are coming? Just try to understand. These are the parameters at the starting layer. These are my words, but machine also has these numbers, and these numbers can be in various layers. And sometimes try to understand that this is only 1% of the total model parameters. They're the machines which is doing the heavy processing. It is having 99% of these parameters. But the whole sole point is, if you combine them, these are 100%, and these are making this model. This is the model intelligence. This is the model understanding, which it is gathered by feeding lots and lots of data, by changing, by improving itself again and again, billions of times, so that it gets this number, so that it gets aligned all these words, right, in the multidimensional space. Having said that, now I'm open for question, and we have question from Aditya. Aditya ji, please ask a question. Please go ahead.
Hey, hi Vishnu. The question is like in your example, right? You had the eight words, right? So based on in the like in one of the example you showed like I love mangoes.
Yeah.
So post I love like it was trying to predict something, and when it comes to mangoes, the prediction was around 90% is what you told,
Yeah.
right?
Yeah.
Okay. In that context, Vishnu, what if we have nine words in the list or the dictionary, um, and the word could be like traveling or sunset, sunrise, something like that.
Yeah,
I'm
which
just
this
trying to
model has
understand.
never heard, right?
Yes,
Yeah.
yeah. In that scenario, how like how the prediction works is what I'm trying.
That is phenomenal question. Actually, you have raised one thing from the next lecture. So actually the key here is, see, I have written all the words from a language which are correct, right? If we talk about in the
Okay.
real example, it is going to be the 1 lakh word, whatever we have. But actually, these are not the real words. Means all the famous word, whatever we have, these are going to be in this. But there are some little or the or you can say pieces of the word also there. For example, if I have unbelievable word, then unbelievable, three words will be there, right? And that is why we are not calling them as a words, we are calling them as a token. Token has a specific property, and we will be talking about this in the next class. So if we have a token, and this is the whole sole point, that human always generate new sentences, and there would be new words also, right? But we believe that these new words will be coming from existing words only, right? For example, believable was there, and then unbelievable come, right? So if we know the overall meaning of unbelievable, we can figure out the meaning of unbelievable. So if another word like traveling comes, right, which is never ever listened by this model, it will try to make it using its tokens, right? And tokens are formed in such a way that, so for example, we will be having 1 lakh to 1 lakh 50,000 tokens. We can make any word of the future also from this. Okay. Maybe one token is A, B, C, D, E also sometimes, right? And mostly if we combine them, we can make any word which may come in future also, right? And we'll try to figure it out the meaning using the smaller words, whatever we have in this model right now. Okay. Am I making any sense,
Sure.
Aditya ji? Yeah. So
Yes.
just wait
Yes.
for the
Yes.
tomorrow, the next class, and I will be talking about tokens. So tokens is the topic of the next step. Next.
Okay. Thanks, Vishnu.
Then we can ask Saradhi Lakshmi Narsimhaji. Please ask your question.
Yeah, hi Vishnu.
Hi.
Good evening.
Good evening.
So I had a similar question as Aditya, and also the other one was like you said that the model is something which is already trained, and the values are frozen, right?
Yes.
So if we are downloading, as you said, Olama, and if we are asking something which it has not been trained, so the output would be wrong.
Output will be wrong or hallucination, right? It is
And
going
it
to
will
generate
not get,
something. Yes, yet it will generate
and also
something
it
on
will
its
not
own.
be trained, right? It will
Yes.
not be trained also because it's frozen.
Yes. And one more thing, and it's very, very interesting. So let's talk more about it. So suppose we have this model which is trained till 2024, right? But believe me, as I mentioned, that if I talk about ChatGPT, the engine is LLM, but it is not the entire ChatGPT. So first thing first, without an engine, there is no car. So without an LLM, there is no ChatGPT. Once this model was pre-trained, this whatever we have done is known as pre-trained, right? Once it is pre-trained, what we do a post-train also, because this was just predicting the next word, right? And it is forming the sentences, paragraph, and it is generating the English language very well. But it doesn't know how to talk to people, right? So what these guys did, these guys sit with maybe 50 or 100 people across the world, and they teach it that if people are asking this, starting reply should be this, and then predict the next word, whatever, right? So that basically it doesn't do anything wrong. It doesn't say anything bad. But yes, you have seen multiple models hallucinate. For example, if it doesn't train on something, right, but it will try to generate something, correct? If it is trying to generate,
Yeah.
the procedure is going to be same. It is predicting a location, and it will predict the nearest word of that location. And that is why sometimes you see that it is telling you something which makes sense, which is pure English, right?
Mhm.
But it is not there at all. It is not right, and that is hallucination. And
Right.
there is going to be, I think, 20 minutes talk on this in future. But your question is really great.
Okay. Yeah. So this was the question, and there is a follow-up question
Mhm.
for that. Maybe you will answer it later. But the
Uh-huh.
question was like, if this is wrong, which we know as a humans when we read that output,
Uh-huh.
how is that the model is being trained without humans? Because you said
Uh-huh.
humans cannot go and give training, right? So uh, is that again a program which is correcting that this is a
Yes.
wrong statement?
Yes. So basically, the post training I'm talking about is that these are the real humans, right? They
Okay.
are chatting
Okay.
with it, they are getting the answer, and they are teaching it again. No, you can't say it like this. You can't. For example, if you say to ChatGPT that your answer is wrong, it is going to say the sorry that sorry, and I want to tell you that I was wrong. Who taught these things, right? These are the result, because see, they, whatever we have done, whatever we have built as this model, it is known as GPT, right? Pre-trained transformer. Then we have
Okay.
to make this as an application which is a chat GPT, which can do the chat also, right? And that is where
Okay.
post training come into picture. What chat GPT did in 2022, it opened this for the public also, right? And
Mhm.
then we talked, and then it get the response. Then it get a lot of thrashing also, that why are you respond? And that is why how chat GPT was learning from our responses also, right?
So that means, yeah, so that means it can also learn wrong way, because if the person or the whoever is training it in a wrong way, it can also
100%,
learn.
100%. You are right. I am saying that,
So
see,
so
whatever.
the
Yeah, please, please go ahead. Mhm.
so the point was like, how will it be trained that something is being taught in a wrong way? Who will do that?
Yeah.
Way to check
So
that.
yeah. Basically, it is going to be then human intervention. A lot of people will come and teach this, and that is again the part of post training. But the major part is done. Try to understand. It is not the case that it is going to tell you the hallucination. The, for example, till 2024 we have taught it, right?
Mhm.
Now this teaching, the various articles. Do you think that all the articles written on the internet are correct? There are some biased in it, right?
That's true. Yeah,
Yeah,
that's
and
true.
then
So
basically in this 2024 also, when you ask something, for example, most of the time when we talk about a doctor, the previous version was thinking on its own that the doctor is a male, right?
mhm.
But it is not true. Means girls are out, women are also doctor, and basically it has some bias with respect to all the things, and we have to remove those bias, and that is what these people have done, these companies have done, right? Maybe they have written
Okay.
a program for it how to teach, but this is part of the post training, because whatever you have learned over the, see, they need quality articles, they need quality information. But if you are training your model on the entire internet, correct things are there and the bad things will also be there for sure. And
Yeah, yeah.
these people needs to post train them also, right? And that is why it happened with
Okay.
the, means when Google launched the Gemini, to try to understand, means in that meeting itself, right? And the public meeting itself, it has written something very bad, which was never intended, right? So
Okay.
yeah, even on the train data 2024, I'm not talking about on to 25 26 it can hallucinate, but even on the train data also it can write something which is not pleasant, because the quality was not pleasant, right? When we taught it, so biasness will
Okay.
be there. But it is very good that we are trying to understand why things happen that way. So maybe bias I will be talking 10 minutes in some class, but this is good. Thank you so much for the question. Now let's take the question from Mr.
Thank you.
Burak, please go ahead.
Okay, thank you, Vishnu.
Mhm.
My first question is it possible to run multiple LLMs at the same time on the machine to get, let's say, better results?
Interesting. But how you are going to combine the result of one LLM with other, I have to see. But I have seen interfaces that if you write one prompt, right, it will go to every other LLM and it will reply, right? So you can see what LLMs are reply. But I am not sure how to combine the weight of all the LLMs so that you can get the result. That
I
thing I need
don't
to check.
know also.
Yeah,
It's
that thing I need
just
to
an
check.
idea.
No, but this is very, and you ask always such questions which really excite my curiosity. So I haven't done that, but recently I could see a program where you can see all the DeepSeek, you can see Claude, you can see a ChatGPT. When you do a query, it is going to be on everybody, and everybody will be responding. So you can see the response and the difference. But how to combine the power of Claude and ChatGPT? This is something which I have unexplored, or whether it can
I
be
see.
possible. Yeah, but
I
great
see.
question. Yeah.
My second question is, if we lose one packet, just one packet, all the training phase starts from the beginning, as far as I know. Why that happens? And also, why do we need lossless networks for the AI,
No, you
especially in the training phase?
can you say the first thing to begin with? What is the when it fails? What did you say? Miss, can you repeat the first question?
If we lose one packet, just one packet, all the training phase
Oh, is it?
starts from the beginning.
Oh,
Yeah.
okay. Okay. I haven't read it from this perspective. That why basically
Mhm.
we need a lossless network here. But give me a chance. Miss, give me some time. I will be doing research. To
Mhm.
be frank, I do not have any idea about it. But I
I
have
see,
written down your
because
question. Yeah.
when we read similar or some articles
Mhm.
about the AI infrastructure, they always told us that please prepare for the lossless network.
Hmm.
What's the reason behind that?
Okay,
I'm
no, I,
trying
I
to
got your
understand
question,
this.
but I really don't have any answer for it. But it's a very interesting question, and I'll give you answer. Maybe in the next.
Okay.
I'll include it.
Okay. Thank you. Thank
Perfect.
you.
Praveen GS, please ask your question.
Yeah, so my question is that, for example, if I'm using some paid subscription for Claude, right? So it gives me an option which LLM to use, right? So for example, Claude Fable or Opus, right? And somehow basis the response, right? So the paid version has actually got better response and then shorter time versus the normal ones. So
Right.
so but then how do they distinguish between those two, right?
Maybe the training, maybe the post training is way more on Fable as compared to their lower models. Maybe the quality which they use during the post training or the pre-training also on which the model is trained is a bit different. I do not know how they are maybe controlling the quality, but some mechanisms should be there so that they can say that maybe this is paid version. It should give you this kind of reply. Maybe they can tweak the parameters. It's all about the weights and the parameters, right?
Yeah.
So,
Yeah.
but you are right that how they are controlling, I really don't have idea about it. But these are some interesting questions. Means I would love to hear from you on the WhatsApp, but I will definitely do a bit of more research on this. So, but I don't have clear understanding of this, how they are controlling between different models. Praveen.
Yeah. Yeah.
Yep.
Okay. That's fine. Thanks.
Deviji, ask your question and then we can. Okay, we have another question. Devi, if you have any doubt, any question, if you're talking, you're
Yes,
on
sir.
mute. Yeah.
So, sir, my first query is in this example. Let's say I have let's say 3 words of language. Like I love mango, I love apple, I love orange. So I have 5 words. I love apple, orange, and mango. How the LLM will decide which word to choose? There are all these possibilities should be having the same rate or same um, distance.
Yeah, maybe that is why it replies different for the same input always, right? For example, means if I give the same input to Claude and you give the same input to Claude, it will reply in a different manner because the next word, whatever it is guessing, right? It might be the case that out of 1 lakh word, there are many words which are on the same probability, right? So
Right.
if it choose the next word here, the answer will be changed accordingly, right? Next word, next word, next word. And that is why we get the different results when we have the same input. But if two different person type, it is going to give you the different result. It is generating the different result. And the reason I think is clear now. Right,
Right.
Devi?
And now, yes. And
Uh-huh.
one more thing is that um, each model should be trained for each task. Right? Like let's say you have a library of languages like words, which will help LLM create a essay or some texting. But how that same LLM is using those same library to create a code, like the coding or like let's say programming or the configuration, that
Yep.
should be a different.
Yeah, maybe. So for example, there is a separate LLM or maybe the same LLM, right? They would have trained or pre-trained or post-trained on enormous amount of coding, right? They have taken codes from all over the Git, and I think they have taken. So that, see, at the end of the day, coding is also a language which is more close to computer, right? And if we can model our language, the English language, which cannot be in rules, we can definitely model the programming language. So it all depends on the input, right? It all depends. Means if a particular model is way way more good as compared to language in, or is really good in the coding, maybe the pre-training is done mostly on the Git or GitHub or maybe the coding platforms, or lots and lots of code has been into this model, right, Debiji?
Yes,
Yeah.
maybe yeah, yes.
Mr. Tarun, please ask your question.
Yeah, sure, Vishnu. I'm just curious to understand, like, as a the chat GPT, the developer, how would I ensure my machines, the performance, like, the millions of users could be using it, whether this particular, LLM is giving the accurate results, or, is it making any mistakes? And how would I ensure that, it doesn't repeat, it doesn't make any mistakes?
Maybe some automatic system they have developed, but that is all part of post training, right? For example, means if I am doing means I am evaluating Claude, I have asked something to the Claude using my prompt, and it has replied that no, that this is the answer, and I said no, you are wrong, right? And maybe such type of conversation go into their system, which immediately sees it that yeah, it's a problem, where Claude has say yes, I am sorry, and I have to go back and check, and maybe then this will become the feed to post train the same model or the different model, right?
Okay.
But
Thank you.
I means how these companies are working to refine their model, that is kind of a different thing. But means we can just have a look at that part things they are using. But the important piece is that we understood the nitty gritties behind LLM, not to a level, not to a mathematics level, but we understood a bit, right, Tarunji?
Yep. Yep.
Perfect.
Thank you.
Sangeeta, Sangeeta ji, please ask your question.
Yeah, my question is, if let us suppose, like I'm just searching anything over Copilot or any chatbot. So what happens, like if I'm just simply searching, like just tell me about this. If I'm just writing one prompt, so what happens? Like it immediately gives me like output. But instead of that, if I write prompt like that, I just give me this information in either in Word document or whatever. So or PDF. So what it's like doing? So it's a like I can see there like coding and executing as well. Like code is coming and then just that is just going to be executed. Why that is happening? Like for that document only, like we are observing coding. If we are searching simply, if we are writing simple prompt, so that is not doing that thing in that case. So why is
No,
this
I,
is the
I
scenario?
I got your question. So basically, when you say that to produce result into a specific format, like MD or the Word, right? So
Yeah, right.
these systems are not trained on basically how to generate the Word file, right? So basically, and that is what I said. This LLM, whatever we are talking about right now, it is just the engine, right? But
Right.
after engine, there are so many things in a car. So right now here, basically, if we want anything in Word, so they might be having a Word environment, right? So suppose a user is asking something in Word, so they will be fetching this, and maybe it requires a bit of coding, right, to fetch this item from here. For example, previously when I used to ask uh, Claude to generate a PNG file, it it said that it doesn't have that capability, right? But then they have introduced something called PNG to generate the PNG file also, maybe to PDF
Right.
file also. So
Mhm.
to call them, maybe LLMs need some kind of coding, right? They might be writing something so that they can generate word, but that is outside the scope of LLM. That how they have built a complete car or basically the complete model. So Chat GPT or this Claude is just not LLM. They have written so many things on top of it: post training, word environment, uh, your PDF environment, and so many things others. So this
So
might be
it's
the
mean
case.
so it's mean like LLM is not supporting that directly, like if we just wanna generate in any particular format. So
See
that
it.
is not supporting. Mhm.
See, it is generating the next word. That is the whole sole purpose of LLM, right? Whatever it is doing after that, responding you with the with your name and saying hello friend or something, that is the effect of post training, right? If it is replying you in Word, it doesn't know Word at all, right? How to generate means Word is a complete program. It can't write anything in Word just like that, right? So maybe it can use those APIs so to generate something in Word. So it might be using some code to fetch behind the scenes whatever is happening and giving you the output. Maybe I'm not sure whether it is giving you something in Word as the output, right? I think nowadays it is giving an MD file the output, and then you can get it in the form of PDF. I'm not sure
Actually,
on
I
that. Yeah,
tried with PDF. I'm
yeah,
not sure about that word. Yeah, even yeah.
yeah.
Okay.
Because in Claude I get in MD5 and I can download it as a PDF. But this is something they have created around LLM so that users are satisfied, right?
So yeah, I understand that. Like there might be something. So you wanna say like LLM is just simply telling about answers only. It's not giving in particular format. If let us suppose I'm just writing, just give me this output in bullet points or something like that. So in that scenario, LLM will support. But if I just want in like output in one particular format, so that won't be supported by LLM. So it will use
Yes,
something else. You wanna
yes,
say like that?
yes, correct.
Okay. 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 Thank you.
Perfect. We have question from Mr. Lalan also. Lalanji, please ask your question. Go ahead.
I guess there is somebody ahead on me. PG.
Oh, yes. Okay. Praveen GS, please ask your question. Mr. Praveen GS, if you're talking, you're on mute.
No, my question is answered. So just.
Okay, perfect. Lalanji, you are good to go.
Sure. Yeah. I have a very short question. I understand you are trying to give us right now just to preface how things are, like all those words as mapping and getting the mapping point, how it comes close together.
Right.
So I want to see, like, if there's I mean, since you are talking about that, the machine, whatever the machine is calculating and doing all those calculations behind the scene to making that model, right? So is there any screenshot or kind of those scenario? I mean, we just see that like preface to, I mean, in the real time, that will be helpful.
I'll show you. Means I'll run Olama in the next class.
Oh, you're gonna do the next class.
Yeah,
Okay,
yeah, yeah.
that's perfect. Yeah. So,
We will be doing that.
I mean, yeah, that's what my concern was like. I mean, I can
But the
visualize these
problem
things,
is,
but if yeah,
Lalan bhai, the problem is if I directly show you downloading Olama, you won't be figuring out what exactly is happening. Now, if I show you the files, you will, Arey, these are the weights. Arey, these are just a simple program to read it. Now you can
sure,
relate with it. And now when you
got
ask a
it.
simple
Sure.
question, even if you remove your internet connection, it is going to generate. Now you will be in position, in situation to explain to yourself that how it is working. Right? This is the whole
Yeah,
scenario.
that will be perfect. Yeah,
Yeah.
yeah, that will be perfect. If that's coming in the next class, perfect. No, I was just lacking that knowledge. Like I can visualizing these things, whatever you are saying here, right?
Yeah.
I can visualize those. But like if I see in the real time in
Yeah,
the
there is no
let's say
point.
the llama,
You are
right,
right. If
and
there is
how
no
those
point if
words
I
are
don't, yeah,
arranged.
correct. There is no
Yeah,
point if I
yeah.
don't show
Thank
it.
you.
Yeah, I will showing it.
Yeah, yeah. Thank you.
Perfect.
Thank you so much.
Okay, then I think we are good. We are already 1 hour and 36 minutes because of your lovely questions. Some I able to answer, I was able to answer, some I couldn't, and extremely sorry. But yes, I will do a research on it and come up in the next class. Having said that, bye for now. See you in the next class. Probably. Yeah, go ahead. Burak.
Sorry, Vishnu. Do you want me to send my questions over WhatsApp?
It is going to be great, Miss. So, guys,
Okay,
whatever I
okay.
haven't
I will.
answered, just type on the WhatsApp so it is in the record. Okay.
Thank you. Bye bye.
Okay. So, what one? Thank you so much for your lovely emojis, guys.